Hello there, and welcome to this quiet corner where curiosity can slow down and science unfolds without hurry. Tonight, we're not rushing toward answers or chasing after certainties. Instead, we're settling into something deeper, something that invites us to imagine the unimaginable and ask what might happen if the very foundation of our existence suddenly shifted beneath us. Picture this. You're lying in bed right now, maybe drifting towards sleep, maybe just letting your mind wander. The world feels still around you, peaceful, predictable. But underneath that stillness, something extraordinary is happening. Something so constant, so fundamental to everything you know, that you never think about it. Right now, as you listen to these words, you're hurtling through space at over 1,000 miles per hour. Not in a car, not on a plane, but simply by existing on the surface of our spinning planet. Earth rotates once every 24 hours, a rhythm so reliable that we've built our entire understanding of time around it. Day follows, night follows, day in an endless cycle that has persisted for billions of years. It's the heartbeat of our world, the invisible force that shapes everything from the way water swirls down a drain to the patterns of wind that carry clouds across the sky. This rotation is so woven into the fabric of reality that we barely notice it exists. But what if it stopped? What if, in some impossible moment, Earth's rotation simply ceased? Not gradually, not over centuries or even years, but suddenly, completely. What would happen to you, to everyone you know, to the world as we understand it? It's a question that sounds like science fiction, but the physics behind it are very real. And the answer is both fascinating and terrifying. Tonight, we're going to explore this scenario not as a prediction or a warning, but as a thought experiment, a way of understanding just how delicate and interconnected the systems are that make life on Earth possible. We'll move slowly through the implications, letting each consequence unfold naturally, because this isn't just about destruction or catastrophe, it's about the hidden elegance of a world in motion, and what happens when that motion stops. If you're the kind of person who wonders about the forces that shape our reality, who looks at the ordinary world and sees the extraordinary mechanisms beneath, then you're in the right place. And if this gentle pace of discovery appeals to you, I'd be grateful if you let the algorithm know by tapping that like button. It helps these questions reach other curious minds who might appreciate this slower approach to understanding our universe. So settle in, let your thoughts drift to the rhythm of our exploration, and prepare to imagine a world transformed. Because before we can understand what would happen if Earth stopped spinning, we need to appreciate just how much depends on the fact that it never does. The first thing to understand is that Earth's rotation isn't just about the alternation of day and night, though that's the most obvious effect. It's a fundamental force that shapes the planet's physical structure, its climate systems, its magnetic field, and the very possibility of life as we know it. When we talk about Earth spinning, we're describing a massive sphere of rock, metal, and water, weighing approximately 6 trillion kilograms, rotating at incredible speeds while hurtling through space. At the equator, the surface of Earth moves at roughly 1,040 miles per hour. That's faster than the speed of sound. If you're sitting closer to the poles, you're moving somewhat slower, but still at hundreds of miles per hour. Right now, as you listen to these words, you're part of this cosmic dance, spinning through space at velocities that would seem impossible if we weren't so accustomed to them. This rotation creates what physicists call the Coriolis effect, an invisible force that influences everything from the direction hurricanes spin to the way ocean currents flow around the globe. It's why storms in the northern hemisphere rotate counterclockwise, while those in the southern hemisphere spin clockwise. It's what drives the great oceanic currents, like the Gulf Stream, which carries warm water from the Caribbean toward Europe and keeps places like London from freezing despite their northern latitude. The Coriolis effect also shapes the winds that distribute heat and moisture around the planet, creating the trade winds that have guided human navigation for millennia. These patterns are so fundamental to Earth's climate that without them, the planet would be utterly different. Weather as we know it depends entirely on the complex interactions between Earth's rotation, its atmosphere, and the energy from the sun. But rotation does more than influence wind and water. It actually changes the shape of the planet itself. Earth isn't a perfect sphere. It's an oblate spheroid, slightly flattened at the poles and bulging at the equator. This bulge exists because of centrifugal force, the same force that pushes you against the door of a car when it takes a sharp turn. As Earth spins, this force pushes material outward, creating a subtle but significant distortion in the planet's shape. The equatorial bulge amounts to about 26.5 miles of extra radius compared to the polar regions. That might not sound like much on a planetary scale, but it has profound implications for everything from the distribution of Earth's oceans to the way gravity varies slightly from place to place. Objects actually weigh less at the equator than they do at the poles, not just because they're farther from Earth's centre, but because the centrifugal force partially counteracts gravity. This rotation also plays a crucial role in generating Earth's magnetic field through a process called the geodynamo. Deep within the planet's core, liquid iron moves in complex patterns driven by the combination of heat, pressure, and rotation. This flowing metal acts like a massive electrical generator, creating the magnetic field that extends far into space and protects us from the solar wind and cosmic radiation that would otherwise strip away our atmosphere. The magnetic field is more than just a shield. It's what makes possible the aurora borealis and aurora australis, those ethereal curtains of light that dance across polar skies. It's what allows migrating animals to navigate across vast distances using internal magnetic compasses. It's what keeps our atmosphere from slowly bleeding away into space, the way Mars lost much of its atmosphere billions of years ago when its magnetic field weakened and failed. All of these systems, from the circulation of air and water to the generation of Earth's protective magnetic field, depend on one simple fact: the planet spins. It has been spinning for over 4.5 billion years, ever since the early days of the solar system when countless collisions between rocky bodies gradually accumulated into the world we know. The rotation we experience today is the legacy of all those ancient impacts, a kind of cosmic momentum that has been preserved across geological time. But what would happen if that momentum suddenly vanished? The first and most immediate consequence would be governed by a principle that Isaac Newton described centuries ago. An object in motion tends to stay in motion unless acted upon by an external force. If Earth suddenly stopped spinning, the planet itself would cease its rotation, but everything on its surface would continue moving at the speed they had been travelling moments before. Imagine you're in a car travelling 60 miles per hour when it suddenly hits a brick wall and stops instantly. Your body doesn't stop with the car. You continue moving forward at 60 miles per hour until something, usually the seatbelt or airbag, forces you to stop as well. Now imagine that same scenario, but instead of 60 miles per hour, you're travelling at over 1,000 miles per hour. That's what would happen to everything on Earth's surface the moment rotation ceased. The atmosphere, moving at over 1,000 miles per hour at the equator, would continue its motion even as the solid planet stopped beneath it. This would create winds of unimaginable violence. Hurricane force doesn't begin to describe them. These would be winds moving at hypersonic speeds, faster than any tornado, faster than the most powerful jet engines. Every building, every tree, every mountain that isn't firmly anchored to the bedrock would be swept away by this atmospheric tsunami. The air itself would become a weapon, carrying with it everything it encountered. Cars, houses, entire forests would be picked up and hurled across the landscape at supersonic speeds. The destruction would be complete and instantaneous across most of the planet's surface. But the atmosphere wouldn't be the only thing continuing its motion. The oceans, containing over 1.3 billion cubic kilometers of water would also keep moving. Imagine tsunamis not hundreds of feet high, but miles high, racing across continents at the speed of sound. The water in Earth's oceans would become a global flood of unprecedented proportions, scouring the surface clean of almost everything humanity has ever built. Even if you could somehow survive the initial catastrophe of the atmosphere and oceans continuing their motion, while the planet stopped, you would find yourself on a world utterly transformed. The very shape of the continents would begin to change as the planet, no longer held in its oblate form by centrifugal force, started to become more spherical. Remember that equatorial bulge we talked about? Without rotation to maintain it, gravity would begin pulling that extra material back toward the center of the planet. But this wouldn't happen uniformly or quickly. The process would involve massive geological upheavals as the crust adjusted to its new shape. Mountain ranges would shift, new fault lines would appear, earthquakes of magnitudes never before recorded would shake the planet as it literally reshaped itself. The redistribution of mass would have another consequence that might surprise you. As the equatorial bulge flattened and Earth became more spherical, the oceans would redistribute as well. Currently, the extra water held at the equator by centrifugal force would rush toward the poles. But this wouldn't be a gentle process. It would be another kind of catastrophe, as sea levels rose dramatically in some areas while dropping drastically in others. The new geography would be unrecognizable. Coastal cities that survived the initial atmospheric and oceanic devastation would find themselves either hundreds of miles inland or completely underwater. The Amazon rainforest might become an ocean floor. The Sahara Desert could be covered by a new polar sea. Mountain ranges like the Himalayas might become island chains in vast polar oceans. But we're only beginning to explore the consequences of a world without rotation. The immediate physical devastation would be just the first chapter in a much longer story of transformation. Because once the initial chaos settled, once the atmosphere and oceans found their new equilibrium in a world without spin, the survivors would face challenges that go far deeper than destroyed buildings or altered coastlines. They would face the slow death of the systems that make Earth habitable, starting with the very rhythm of day and night that has governed life for billions of years. Without rotation, the concept of day and night as we know it would cease to exist. Instead of our familiar 24-hour cycle, Earth would become tidally locked with the sun, just as the moon is tidally locked with Earth. One hemisphere would face the sun continuously, bathed in eternal daylight, while the other would remain in perpetual darkness, never again to see sunrise. Think about what this means for a moment. Half the planet would experience a day that lasts 6 months, followed by a night that lasts another 6 months. But even this description doesn't capture the full strangeness of what would unfold. The hemisphere facing the sun wouldn't just receive daylight, it would receive unrelenting solar radiation with no rotation to distribute the heat around the globe. Temperatures on the day side would climb steadily, hour after hour, week after week, month after month. Without the cooling effect of night, without the moderating influence of atmospheric circulation patterns driven by rotation, surface temperatures would soar well above the boiling point of water. The day side would become a furnace, an inferno where no known form of life could survive. Meanwhile, the night side would experience the opposite extreme. Cut off from all solar energy, temperatures would plummet far below anything currently experienced on Earth's surface. Not just the cold of an Antarctic winter, but the bitter cold of deep space itself. The night side would become a frozen wasteland, where even the atmosphere might freeze solid and fall as snow. Between these two extremes would lie a narrow band, the Terminator line, where the day side meets the night side. This boundary region would become the only place on Earth where temperatures might remain within a range that could possibly support some form of life. But even this zone would be far from hospitable. The temperature differential between the blazing day side and the frozen night side would create pressure gradients unlike anything Earth has ever experienced. Air from the hot side would rush toward the cold side with incredible force, creating permanent hurricane-force winds along the Terminator line. These storms wouldn't be temporary weather events. They would be a permanent feature of the new world, raging continuously as hot air perpetually seeks to equalize with cold air that can never warm up. The violence of these eternal storms would make the Terminator zone nearly as inhospitable as the extremes it separates. Imagine winds that never stop, that never calm, that blow with the force of the most powerful hurricanes ever recorded. The sound alone would be deafening, a constant roar that would make communication difficult and rest impossible. But the transformation of Earth's climate would involve more than just temperature extremes and perpetual storms. The entire system of atmospheric and oceanic circulation that currently distributes heat, moisture, and nutrients around the planet would collapse completely. Consider the Gulf Stream, that river of warm water that flows from the Gulf of Mexico toward Europe. This current exists because of the Coriolis effect, the same rotational force that shapes weather patterns around the globe. Without Earth's rotation, there would be no Coriolis effect, and without the Coriolis effect, the Gulf Stream would simply stop flowing. The same would be true for all the major ocean currents that currently regulates global climate, the Kuroshio current that warms Japan, the Peru current that brings nutrients to South American fisheries, the Antarctic circumpolar current that connects the world's oceans. All of these would cease to exist. The ocean, instead of being a dynamic system of flowing currents that distribute heat and nutrients, would become largely stagnant. This stagnation would have profound implications for marine life. Ocean currents don't just move water, they move oxygen, nutrients, and microscopic organisms that form the base of the marine food web. Without these currents, vast areas of the ocean would become biological deserts, unable to support the complex ecosystems that currently thrive there. The atmosphere would undergo similar changes. The trade winds that currently carry moisture from the oceans to the continents exist because of rotational forces. Without rotation, these wind patterns would disappear, replaced by the simple flow of air from the hot day side to the cold night side. This would fundamentally alter precipitation patterns around the globe. Regions that currently receive regular rainfall might become deserts, while other areas might experience flooding as atmospheric moisture condenses in new patterns. The Amazon rainforest, which depends on complex wind patterns to bring moisture from the Atlantic Ocean, would likely dry up and die. The same would be true for most of the world's other great forests and grasslands. The disappearance of these ecosystems would trigger a cascade of extinctions. Plants that have evolved to photosynthesize during specific daylight hours would struggle to adapt to either continuous light or continuous darkness. Animals that depend on circadian rhythms, for everything from sleep cycles to migration patterns, would find their biological clocks completely disrupted. But perhaps the most profound change would be the gradual weakening and eventual collapse of Earth's magnetic field. The geodynamo that generates this field depends not just on the movement of liquid iron in Earth's core, but on the Coriolis forces created by the planet's rotation. These forces help organize the flow of molten metal into the complex patterns that generate and maintain the magnetic field. Without rotation, these organizing forces would disappear. The chaotic movement of liquid iron in the core would gradually become less organized, less effective at generating magnetic fields. Over time, perhaps over thousands or millions of years, Earth's magnetic field would weaken and eventually vanish entirely. The loss of the magnetic field would expose the planet to the full force of solar radiation and cosmic rays. These high-energy particles would gradually strip away the atmosphere, just as they stripped away most of Mars's atmosphere billions of years ago. Even if some form of life managed to survive the initial catastrophe of Earth's rotation stopping, it would face the slow but inexorable transformation of the planet into an airless, lifeless world. The technological systems that modern civilization depends on would face immediate and complete failure. Satellites in geosynchronous orbit, which currently appear stationary in the sky because they orbit at exactly the same rate Earth rotates, would suddenly begin moving across the sky as their orbital period no longer matched the planet's rotation. Communication networks, GPS systems, weather monitoring, and countless other services that depend on these satellites would simply stop working. The failure of GPS would make navigation almost impossible, particularly for aircraft and ships that depend on precise positioning. Emergency services would lose the ability to locate people in distress. International commerce, which relies on precise timing and coordination across time zones, would face complete breakdown. But even more fundamental would be the psychological and biological impact on any human survivors. Our bodies, like those of virtually all life on Earth, are synchronized to the 24-hour day through circadian rhythms that have evolved over millions of years. These internal clocks regulate everything from sleep and wakefulness to hormone production and immune system function. In a world of 6-month days and 6-month nights, these biological rhythms would be completely disrupted. Sleep disorders, depression, hormonal imbalances, and compromised immune systems would affect any survivors. The human body simply isn't designed to function under such extreme and unnatural light cycles. The seasonal affective disorder that some people experience during winter months would become a permanent condition for large portions of any surviving population. Mental health impacts would be severe and widespread, adding another layer of challenge to the already impossible task of rebuilding civilization in such a transformed world. Agriculture, the foundation of human civilization, would become nearly impossible. Crop plants depend not just on appropriate temperatures and moisture, but on specific patterns of light and darkness for growth, flowering, and reproduction. In a world of eternal day or eternal night, with only a narrow and storm-racked zone between them, growing food would require completely reimagining agricultural systems. The few survivors would face a choice between the furnace of the day side, the freezer of the night side, and the perpetual hurricane of the Terminator zone. None of these options would offer easy survival, and the technological infrastructure needed to create artificial growing environments would be largely destroyed by the initial catastrophe. As we contemplate this transformed world, we begin to understand just how many of the systems we take for granted depend on something as simple as the planet's rotation. The gentle alternation of day and night, the seasonal patterns that govern agriculture, the ocean currents that moderate climate, the magnetic field that protects us from radiation, even the shape of the continents themselves, all exist because Earth spins. In the silence of this thought experiment, we're confronted with the elegant complexity of our world in motion, and the profound fragility that lies beneath its apparent stability. Yet even as we explore these catastrophic scenarios, there's something almost meditative about understanding the deeper mechanics at work. Because what we're really discovering isn't just destruction, but the hidden architecture of stability that usually goes unnoticed. In the quiet spaces between cause and effect, we find ourselves appreciating systems so fundamental that they become invisible until they're gone. Consider for a moment the simple act of walking. Right now, if you were to stand up and take a step forward, your inner ear would automatically adjust for the Coriolis effect, that gentle deflection caused by Earth's rotation. It's so subtle that you never notice it, yet it's part of every movement you make. Birds flying long distances instinctively compensate for this effect. Rivers curve slightly as they flow. Even the way plants grow and orient themselves carries the signature of a spinning world. Without rotation, the very sensation of movement would feel different. The inner ear, that delicate organ that helps you maintain balance, has evolved over millions of years to function in a world where everything is constantly in motion. In a suddenly still world, the absence of these familiar forces might leave survivors feeling perpetually off balance, as if something essential was missing from their sense of place in the universe. The transformation would extend into realms we rarely consider. Sound itself would behave differently. Currently, the Coriolis effect subtly influences how sound waves travel through the atmosphere over long distances. Without rotation, acoustic phenomena would change in ways we can barely imagine. The songs of whales, which can travel across entire ocean basins, might no longer reach their intended audiences. The complex acoustic landscapes that animals use for navigation and communication would be fundamentally altered. Even more profound would be the changes to Earth's relationship with the Moon. Currently, the gravitational dance between Earth and its satellite is a delicate balance involving rotation, tidal forces, and orbital mechanics. Earth's spin is actually slowing down very gradually due to tidal friction with the Moon, causing our days to lengthen by about 1.7 milliseconds per century. This process has been ongoing for billions of years, and it's part of why the Moon is slowly moving away from Earth at about 1.5 inches per year. If Earth's rotation suddenly stopped, this ancient dance would be disrupted in ways that might affect the Moon's orbit over very long timescales. The tidal bulges that the Moon raises in Earth's oceans would no longer be carried ahead of the Moon by rotation, potentially altering the gravitational interactions that have kept the Earth-Moon system stable for eons. The Moon itself would continue its orbit, but its phases would take on an entirely different meaning. Instead of marking the passage of roughly monthly cycles, lunar phases would become markers of position relative to the day and night sides of Earth. For survivors in the narrow habitable zone, the Moon might become a crucial navigational aid, one of the few reliable ways to track time and direction in a world where familiar patterns have vanished. In the perpetual twilight of the Terminator Zone, where temperatures might theoretically allow for some form of survival, the Moon would appear to move across the sky in slow, stately arcs, taking roughly 29 days to complete each apparent orbit. This would become the new measure of time, replacing the vanished rhythm of day and night with the ancient rhythm of lunar phases. But even in this narrow band of potential habitability, survival would require adaptations that go far beyond anything humans have ever faced. The constant winds, driven by the temperature differential between the day and night sides, would create acoustic environments unlike anything on current Earth. The sound of these perpetual storms wouldn't just be loud, it would be omnipresent, a constant reminder of the planetary forces at work. Any vegetation that might survive in this zone would need to adapt to conditions that have never existed in Earth's natural history. Plants would need to photosynthesize in the filtered light of perpetual dawn or dusk, while anchoring themselves against winds that never cease. The evolutionary pressure would be immense, and most species simply couldn't adapt quickly enough to survive the transition. Those organisms that might endure would likely be extremophils, species that already exist at the edges of what life can tolerate. Deep-sea creatures adapted to high pressure, and no sunlight might find refuges in the deepest ocean trenches. Certain bacteria and archaea that thrive in extreme temperatures might colonize new niches created by the planet's temperature extremes. But the complexity of ecosystems as we know them would be lost. The intricate food webs that support biodiversity depend on countless species, filling specific niches, and most of these niches would simply cease to exist. The Amazon rainforest supports an estimated 400 billion individual trees and countless species of animals, insects, and microorganisms. All of this would be gone, replaced by a world so simplified that it would be almost unrecognizable as the same planet. The psychological impact of living in such a transformed world extends beyond the biological disruption of circadian rhythms. Humans are creatures of pattern and rhythm. We find meaning in cycles, in the predictable return of familiar conditions. The sunrise that never comes, the night that never ends, would represent not just physical challenges, but existential ones. Cultural practices built around daily and seasonal cycles would lose their meaning. Religious observances tied to solar and lunar events would need complete reinterpretation. The very language we use to describe time, with its references to morning and evening, dawn and dusk, would become relics of a world that no longer exists. Children born in such a world, if any could survive, would grow up with no understanding of the rhythms that shaped human consciousness for millennia. They would know only the eternal storm, the unchanging twilight, the absence of those gentle transitions that have always marked the passage of time. Their psychological development would unfold in ways we can barely comprehend. The absence of seasons would eliminate one of the fundamental organizing principles of human culture. No longer would there be times for planting and harvest, for celebration and reflection, for the natural ebb and flow of activity that has shaped civilizations since the beginning of agriculture. The very concept of seasonal affective disorder would become meaningless in a world where the entire surviving population would experience constant environmental stress. Yet perhaps, in the deepest consideration of these changes, we begin to understand something profound about resilience and adaptation. Life on Earth has survived ice ages, asteroid impacts, massive volcanic eruptions, and dramatic changes in atmospheric composition. Each time something persisted, found a way to continue, to evolve, to eventually flourish again. The microorganisms living in the deepest parts of the ocean, sustained by chemical energy from hydrothermal vents, rather than sunlight, would likely be the least affected by Earth's rotation stopping. These creatures, existing in an environment already isolated from surface conditions, might continue their ancient cycles largely undisturbed. In the profound darkness of the deep ocean, where temperatures are already near freezing and no sunlight penetrates, the transformation of the surface world might barely register. These deep-sea communities represent a different kind of ecosystem entirely, one based not on the sun's energy, but on the Earth's internal heat. Bacteria that metabolize sulfur compounds, tube worms that have never known sunlight, fish that navigate by bioluminescence rather than solar cues, all might persist in their alien world beneath the chaos above. In time, perhaps over millions of years, these deep refugees might become the seeds of recovery. Evolution, that patient process that has shaped life for billions of years, would continue its work even in this transformed world. New forms adapted to the strange new conditions might gradually emerge and spread. The Terminator Zone, despite its harsh conditions, might eventually develop its own unique ecosystems. Plants might evolve to thrive in perpetual twilight, developing new forms of photosynthesis adapted to the filtered light. Animals might adapt to the constant winds, perhaps developing new forms of locomotion or shelter-building behaviors. Over geological timescales, the planet itself would continue to change. The redistribution of water toward the poles would create new continental configurations. Mountain ranges might rise in new locations as tectonic stresses adjust to the planet's altered shape. Volcanic activity, triggered by the massive reorganization of mass, might eventually create new landforms and even new atmospheres through the release of gases from the Earth's interior. But these are changes that would unfold over millions of years, timescales so vast that they dwarf human history. For any immediate survivors of the rotation cessation, the focus would be on much more immediate concerns: the basic requirements of shelter, food, and water in a world where all three had become almost impossibly difficult to secure. The engineering challenges alone would be staggering. How do you build structures that can withstand constant hurricane-force winds? How do you generate energy when solar panels would be useless on the night side and might overheat on the day side? How do you purify water when the hydrological cycle has been completely disrupted? These questions bring us back to an appreciation of the elegant solutions that evolution and physics have already provided. The water cycle that currently operates on Earth, driven by solar energy and organized by rotational forces, is a marvel of efficiency. It purifies water through evaporation, transports it across continents through atmospheric circulation, and deposits it where it's needed through precipitation patterns that have remained relatively stable for millions of years. Wind power, which humans are just learning to harness effectively, represents just a tiny fraction of the energy contained in atmospheric circulation patterns driven by rotation. The trade winds alone move more energy around the planet than all human industrial activity combined. Ocean currents transport even more energy, moderating temperatures and making vast areas of the planet habitable. All of this free energy, this planetary scale machinery that operates without human intervention or maintenance, would simply stop. In its place would be the raw, undirected flow of air from hot to cold, creating not useful energy, but chaotic destruction. As we contemplate these profound changes, we're reminded that the Earth we know is not just a stage upon which life performs, but an active participant in the dance of existence. The planet's rotation is not separate from life, it's integral to it, woven into the very fabric of how biological systems operate and evolve. In the gentle spinning of our world, we find not just the mechanism that creates day and night, but the hidden foundation that makes complexity possible, that allows for the intricate interactions between atmosphere and ocean, between geology and biology, that have shaped our planet into the remarkable world we inhabit. And so, as we drift further into this thought experiment, we begin to understand that we're not just exploring a scenario of destruction, but discovering the profound interconnectedness of systems that usually remain invisible, hidden in the smooth operation of a world that has been spinning without interruption for longer than life itself has existed. In the strange twilight world that would emerge from this planetary transformation, we might find ourselves reconsidering the very nature of home. What does it mean to belong to a place when that place has become fundamentally alien? The survivors, if any existed, would be refugees not from war or natural disaster, but from the basic physics of their own world. They would carry with them the memory of sunrises that will never come again, of seasons that have ceased to exist, of a rhythm of life that has been permanently severed. The concept of nostalgia would take on dimensions we can barely imagine. Every human culture has words for the longing we feel, for places and times that exist only in memory. But what do you call the longing for a world that spun, for mornings that arrived with predictable gentleness, for the simple comfort of knowing that however dark the night became, dawn would always follow? This wouldn't be nostalgia for childhood or homeland, but for the fundamental conditions that made consciousness itself feel natural and right. In the debris of this transformed world, the artifacts of rotational civilization would become archaeological mysteries. Sundials, those ancient timekeepers that marked humanity's first scientific understanding of Earth's motion, would become meaningless objects. The careful alignments of ancient monuments from Stonehenge to the pyramids, all calculated to mark solstices and equinoxes that would never come again, would stand as monuments to a different kind of physics. Even more poignant would be the smaller traces. The growth rings in trees, those annual markers of seasonal change, would end abruptly in whatever year the rotation ceased. Coral reefs, which grow in subtle patterns influenced by tidal cycles, would bear the permanent signature of the moment when those cycles stopped. In ice cores and sediment layers, future archaeologists of whatever species might eventually evolve would find the precise moment when Earth's 4.5 billion year spin finally ended. The survivors would need to develop entirely new relationships with time itself. Without the sun to mark hours or seasons to mark years, how would they measure the passage of their lives? The phases of the moon might become the primary temporal reference, creating a civilization organized around lunar months rather than solar days. but even this would feel alien, stretched and strange compared to the rapid alternation of light and dark that has shaped every human culture. Language itself would begin to evolve in response to these new conditions. Words like morning and evening, dawn and dusk would gradually lose their meaning, becoming historical curiosities like the names of extinct animals. New vocabulary would emerge to describe the permanent conditions of the terminator zone, words for the quality of perpetual twilight, for the sound of winds that never cease, for the particular kind of cold that comes not from winter, but from the absence of a sun that never moves. The children who might grow up in this world would develop psychology unlike anything in human history. Their dreams would not be populated by the changing light of natural days, but by the constant conditions they knew. They might develop entirely different circadian rhythms, or perhaps no circadian rhythms at all, their bodies adapting to the strange reality of unchanging external conditions. Music, that most temporal of arts, would transform as well. The rhythm that underlies all human music, that sense of pulse and measure that connects to heartbeat and breathing and the cycle of day and night, would need to find new sources of inspiration. Perhaps the constant wind would provide a new kind of drone, a planetary tone that would become the foundation for whatever music might emerge from this transformed world. The mathematics of this new world would be simpler in some ways, more complex in others. Navigation, one of humanity's oldest mathematical challenges, would become simultaneously easier and harder. Easier because the sun would be a fixed reference point. Harder because all the traditional methods based on celestial movement would be useless. The North Star would still point north, but it would no longer rotate around its position in the sky, eliminating one of the fundamental tools of traditional navigation. Architecture would need to be completely reimagined. Buildings would need to withstand not occasional storms, but permanent wind stress. The very concept of windows would change, since there would be no daily variation in light to consider. Structures might need to be built underground or carved into cliff sides to provide protection from the eternal gales of the terminator zone. The psychology of shelter would become more profound than ever before. In a world where the external environment is permanently hostile, the interior spaces where humans might survive would become more than mere buildings. They would be complete artificial environments, technological wombs that would need to provide not just protection from wind and temperature, but also the sensory variety that the natural world once offered freely. Imagine the engineering required to create artificial day and night cycles. Within these shelters, the complex systems needed to provide the light variations that human biology craves. These wouldn't be mere conveniences, but medical necessities, essential for maintaining mental health in a world gone mad with stillness. The energy requirements for such survival systems would be enormous. In a world where wind power might theoretically be abundant due to the constant storms, but where traditional solar power would be useless except in the furnace of the dayside, survivors would need to develop entirely new technologies. Perhaps they might harness the temperature differential between the day and night sides, creating thermoelectric generators on a scale never before imagined. Geothermal energy would become more valuable than ever, as the heat from Earth's interior would be one of the few reliable power sources unaffected by the surface catastrophe. The hot springs and geysers that we currently admire as natural curiosities would become the foundations of whatever technological civilization might persist. Water, too, would require completely new approaches to management and purification. The hydrological cycle that currently provides fresh water through evaporation and precipitation would be broken. Instead, water would need to be extracted from ice on the night side, or somehow distilled from the superheated atmosphere of the dayside. Every drop would become precious in ways that current human civilization has never had to contemplate. Food production would face challenges that make current agricultural problems seem trivial. Vertical farming, hydroponics, and other controlled environment agriculture techniques would transition from interesting innovations to absolute necessities. But even these would require complete redesign to function without any external inputs of natural light or climate moderation. The genetic diversity of crops would become a critical survival resource. Seeds stored in facilities like the Svalbard Global Seed Vault would represent not just agricultural heritage, but the difference between survival and extinction for any human remnant. These collections, originally intended to preserve biodiversity for future generations, would become the libraries from which an entirely new relationship with agriculture would need to be written. In this transformed world, the relationship between humanity and nature would undergo a fundamental shift. Instead of seeing ourselves as separate from or masters of the natural world, survivors would be forced to understand their complete dependence on artificial systems. Nature would no longer be something to be conserved or managed, but something lost, existing only in memory and in whatever small ecosystems might persist in the deep ocean or other protected niches. This shift in perspective might lead to new forms of spirituality and philosophy. How do you maintain hope in a world where the fundamental conditions of existence have become hostile? How do you find meaning in survival when everything that once gave life meaning has been stripped away? These questions would challenge human psychology in ways that no previous disaster or transformation ever has. The oral traditions that might develop in such a world would carry stories of the time when the world turned, when mornings came and seasons changed and the sky moved in predictable patterns. These stories would seem like fantastic myths to children, born into the new reality, tales as incredible as any fantasy. The idea that the sun once moved across the sky, that there were times called summer and winter, that the ocean had currents and the air had weather patterns would sound like magic. Yet in the preservation of these stories, in the careful maintenance of memory, even when memory describes an impossible world, something essentially human would persist. The capacity to remember, to mourn, to hope for something better. These qualities might prove more durable than any of the physical systems that the end of rotation would destroy. And perhaps, in the fullness of deep time, when the immediate crisis had passed and whatever remained of Earth's biosphere had found new equilibria, the memory of a spinning world might become the inspiration for something unprecedented. Perhaps survivors would dream of ways to set the world spinning again, to restore the ancient rhythm that once made Earth a garden instead of a wasteland. Such dreams might seem impossible, but then again, the idea of stopping a planet's rotation would also seem impossible to us now. In a universe where such fundamental transformations are conceivable, perhaps the reverse transformation might be as well. Perhaps the knowledge that Earth once spun could become the foundation for technologies we cannot yet imagine, ways of harnessing the forces that shape planets to restore what was lost. These are speculations that reach far beyond the immediate catastrophe, into futures so distant that they belong more to imagination than to physics. But they remind us that, even in the darkest scenarios, the human capacity for hope and ingenuity might find ways to persist and eventually to flourish. In the meantime, as we sit comfortably in our spinning world, these thought experiments serve a different purpose. They help us appreciate the extraordinary conditions that make our ordinary lives possible, the invisible systems that support everything we take for granted, the gentle alternation of day and night, the changing seasons, the winds that bring weather, and the currents that moderate climate. All of these emerge from the simple fact that our planet turns. In understanding what would happen if that turning stopped, we discover not just destruction, but the hidden elegance of a world in motion, the profound interconnectedness of systems that usually remain invisible beneath the surface of daily life. And in that understanding, we might find a deeper appreciation for the remarkable planet that continues, as it has for billions of years, to spin quietly through the cosmos, carrying us all through space and time on a journey that feels still only because we're all moving together through the vast darkness between the stars. But perhaps the most profound tragedy would be the loss of something we rarely think about, the dance of electromagnetic forces that currently protects us all. Earth's magnetic field, that invisible shield generated by the churning of molten iron deep within the planet's core, depends entirely on the Coriolis forces created by rotation. Without the organizing influence of spin, the complex convection patterns in the outer core would gradually become chaotic, less effective, eventually grinding to a halt. This wouldn't happen immediately. The magnetic field would persist for a while, perhaps decades or even centuries, slowly weakening as the geodynamo that creates it lost its driving force. But eventually, inevitably, the field would collapse entirely, leaving Earth exposed to the full fury of solar radiation and cosmic rays. Picture what this would mean for any survivors huddled in their artificial shelters in the Terminator zone. Even if they had somehow managed to create sustainable food production, even if they had solved the engineering challenges of permanent hurricane-force winds and extreme temperature differentials, they would eventually face a threat that no technology could easily shield them from. High-energy particles from space would begin penetrating the atmosphere, causing radiation sickness, genetic damage, and slow death for any complex life forms. The atmosphere itself would begin to bleed away into space, just as Mars lost its atmosphere billions of years ago when its magnetic field failed. This wouldn't be a quick process, but over thousands or millions of years, Earth would gradually transform from a planet with air and water into an airless rock, cold and dead and silent. The irony is profound. In stopping Earth's rotation, we wouldn't just be ending the familiar rhythm of day and night. We would be initiating a process that would eventually strip away the very conditions that make any form of life possible. The planet that gave birth to consciousness would slowly transform into something as barren as the moon. Yet even in contemplating this ultimate ending, there's something almost poetic about the timescales involved. The magnetic field wouldn't disappear overnight. The atmosphere wouldn't vanish in a single generation. These changes would unfold over periods so vast that they dwarf human history, giving any theoretical survivors thousands of lifetimes to adapt, to evolve, to perhaps find solutions we cannot now imagine. In the deep ocean trenches where life already exists in conditions that seem impossible by surface standards, organisms might persist even as the surface world died. These creatures, sustained by chemical energy from the Earth's interior rather than by sunlight or magnetic protection, might continue their ancient existence largely unchanged. They would become the final inheritors of a planet that once teemed with complexity. The thought of these deep-sea survivors carries a strange comfort. Even in the most complete catastrophe we can imagine, life might endure, not human life, perhaps not any form of consciousness we would recognize, but the fundamental spark of biological activity that has persisted on Earth for nearly 4 billion years. In the crushing depths where water remains liquid despite the cold, where chemicals seep from the planet's interior to feed bacteria that have never known sunlight, the ancient patterns might continue. These organisms live in what scientists call chemosynthetic ecosystems, communities powered not by photosynthesis, but by the chemical energy released when certain compounds react with each other. Tube worms clustering around hydrothermal vents, bacteria that metabolize sulfur or methane, entire food webs that exist independently of the sun's energy. They represent a completely different approach to life, one that doesn't depend on the surface conditions that a stopped rotation would destroy. In a strange way, these deep-sea communities might be the most realistic survivors of such a planetary catastrophe. They already live in conditions of constant darkness, extreme pressure, and isolation from surface weather patterns. The chaos above might barely affect them. They would continue their slow, patient existence, perhaps eventually evolving and diversifying to fill new niches as the surface world emptied. Millions of years later, if the planet's interior remained active, if volcanic processes continued to release chemicals into the deep ocean, these communities might even begin to expand and complexify again. Evolution is patient and persistent. Given enough time, given stable conditions and a source of energy, life tends to become more elaborate, more diverse, more surprising. Perhaps new forms of intelligence might eventually emerge from these deep refuges. Consciousness adapted to a world of eternal darkness, minds that navigate by chemical gradients and pressure waves rather than light. Such beings would inherit a planet utterly transformed, a world where the surface is hostile, but the depths remain habitable. They might eventually discover evidence of the previous biosphere in fossils and sediment layers, and wonder about the strange conditions that must have existed when life covered the planet's surface. To them, the idea of organisms powered by sunlight might seem as exotic as deep-sea creatures seem to us. The concept of a world that spun might be a theoretical curiosity, a mathematical possibility with no connection to lived experience. But these speculations carry us far beyond the immediate catastrophe, into futures so remote that they belong more to imagination than to physics. The survivors of a stopped rotation, if any existed, would face challenges much more immediate and pressing than the eventual evolution of new forms of consciousness. They would need to solve the basic problems of existence in a world where all the fundamental assumptions about how to stay alive had been overturned. How do you maintain psychological health when external conditions never change? How do you preserve human culture when the environmental cues that shape that culture have disappeared? How do you raise children in a world that bears no resemblance to the one their species evolved in? And so we return gently to the quiet room where this journey began. You're still here, still listening, still breathing the air of a world that continues its ancient spin. The thought experiment fades, but something remains. An awareness, perhaps, of the invisible forces that cradle every moment of your existence. Tonight we've walked through destruction, not to frighten, but to illuminate. In imagining a world without rotation, we've discovered the profound elegance of a world that turns. Every sunrise you'll witness, every season that arrives, every breath you take exists because our planet dances through space in precisely the way it does. Rest now in this spinning world, knowing that as you drift towards sleep, you're held by systems so vast and intricate that they dwarf human understanding, yet so gentle that you never feel their embrace. The Earth continues its quiet revolution, carrying you safely through the darkness between stars. Sweet dreams, fellow traveller.